Hi, my name is Erin Johnson and I work for the Isaac Walton League. Today I'm going to show you an activity from our Creek Freaks curriculum called the soil percolation test. This is a great activity to introduce students to the properties of soils. So let me show you the materials you're going to need to get started. You'll need 3 2-liter soda bottles with the base cut off, 6 pieces of fine window screen cut into circles, and 3 measuring cups. Water with food coloring. You'll need 3 cups of clay kitty litter ground up in a blender, 3 stopwatches, 3 cups of potting soil or local soil, 4 or 5 cups of sand. So your first step is going to be to cut the bottoms off of your soda cans. So I already have this one cut here. And your second step is going to be to take your window screen, you'll have 2 pieces, put them on top of each other, and attach them to the top of the bottle like this. You'll use some tape to keep that in place. So once these are all taped up, they're going to look like this. So they're taped all the way around here. After you're done taping the screen onto the bottles, you're going to want to place each of them into the measuring cup. One thing you want to do is make sure that the bottom of your soda bottle isn't touching the bottom of your measuring cup here. The next thing we're going to do is add 1/3 cup of sand to each one of these bottles to keep the screen at the bottom clear. After you're done filling each of them with 1/3 cup of sand, you're going to want to add 3 cups of additional material. So in the first one here, we're going to add 3 cups of the potting soil or your local soil. In the second one, we'll add 3 cups of the ground up clay kitty litter. And in the third one, we'll add an additional 3 cups of sand. So now that you've added 3 cups of the different soil types to each of your containers, you're ready to run the experiment. So make sure you've taken your stopwatches out. And some things you want to discuss with your students before you run this would be how fast is the water going to move through each of these soil types, whether the soil is going to absorb any of the water, and how the color of our food coloring water might change from the top to the bottom. So we're going to run the sand first. What you want to do is measure out 2 cups of water. And you want to start your stopwatch right when you start pouring. When you pour the water, make sure that you or your students don't just dump it right in. You want to pour it evenly over the whole container. So we'll start timing when we start pouring. And you're going to watch for when the water starts to come out of the bottom, and that's when you'll stop your time. So you'll wait and watch for the first drip to come out, which is at 21.47 seconds for this experiment. So we ran the sand, and you saw that come through. Now we put the same amount of water. We put 2 cups in our clay soil and in our potting soil, and let those run as well. So as you can see, our clay soil here has yet to reach the bottom. We still have some dry clay here. And our potting soil went through, and we have some water at the bottom. So there's 3 things that you're going to want to discuss with your students about this. The first is the timing. So we had stopwatches for each one, and we timed them from the second we started pouring to the second we saw a drip come at the bottom. For the sand, that was 21 seconds. And for the clay, it's still running. For the potting soil, it was actually 20 seconds. So the story behind this is talking about pore space within soils. The sand we had was very fine, so there was some open air, that pore space in the soil, so it was able to run through, but it did take 21 seconds to do that. The clay has very fine particles, so there's not a lot of pore space, hence why we're still waiting for that to drip through. And the potting soil that we used was very light and fluffy. When we poured the water in, we even had air bubbling up. So there was a lot of pore space in this, hence the 20 seconds that it took to run through. If you're gonna use a local soil, it's probably gonna be a lot longer because that soil is likely to be more dense than this fluffy potting soil that we used. So your results could vary on this one. The other 2 controls here, the sand and the clay, would usually be pretty consistent. So that was timing. The second thing that you can look at is the color of the water that came through. So nothing came through our clay yet, but if we look at the sand, we can tell that the color of the water here differs a little bit from the color that we started with. So that food dye represents pollution. We can see here that the sand was able to filter out some of that pollution. We jump over here to the potting soil. We can also see that there's a different color here. It's not the same as the sand, but it is a little bit lighter than our original starting color. So we can also see that that dirt was able to filter out some of the pollution. So we talked about time, we talked about the colors, and then the last thing we want to talk about is how much water was absorbed. So here you can see the water level here, I'll read it for you, is about 1.5 cups of water that came out. Remember that we started with 2 cups. Here nothing's come out yet. And for the local soil or potting soil, we had about 1 cup come out. So more soil, more water came out of the first sand here, so less water was absorbed in the sand. This potting soil had a lot more organic material and that was able to absorb a lot more of the water. So we can see the 3 differences there. So this is a great introductory activity for your students to get them interested in the topic of soils before you go outside. You can really repeat this experiment as many times as you want. You can have as many soda bottles as you want with different types of soil. It might be a good idea to get some streamside soil, maybe some more upland soil, and compare the two. So it's a good introduction to soils.
For more information and to check out the Creek Freaks curriculum, please visit our website.